All right, we're on to lecture 10 part B right now. And in this lecture, we're going to learn how to name yet another kind of compound, right? So we started off with the ionic. Ionic compounds, metal and a non-metal. Then we talked about, in the last part, molecular compounds, two non-metals. All right, in this lecture, we're going to learn to name acids. So this will be our last kind of compound that we learn to name. Part C, we'll get to in a little later. That'll be on review of all this naming business. So today, this lecture, part B, naming acids. So the first thing you're going to need to know when you name an acid is how can you tell you have an acid? What do you look for in the formula to tell you you have an acid? So let me put up a couple examples. That might help, right? HCl, that's an acid. HNO2, that's an acid. Or H2SO4, that's an acid. So what do you notice all acids have in common? They always start with H. They always start with hydrogen. To be a little exact, hydrogen, and it actually has a positive charge, a positive 1 charge. All right, so if you know you have an acid, and you're going to know because the first element you see in the formula is hydrogen, this is how you name it. So the first thing we're going to do is determine the name of the non-hydrogen part. So for example, what's Cl called? What's NO2 called? What's SO4 called? So we got to know the name of that thing. And once you know the name of that thing, what you're going to do is you're going to use this chart to name the acid. So the way it'll work is if the name of the non-hydrogen part, the other thing in the formula, if its name ends in IDE, the acid that contains it will be called a hydroic acid, a hydroic acid. If when you determine the name of the non-hydrogen part and you realize that it ends in ITE, the name of the non-hydrogen part, that means the acid is going to end in us. We'll switch the ending to us. It'll be an us acid. If you look at the name of the non-hydrogen part, the rest of the formula, and it ends in ATE, the acid, we're going to switch the ending again. It's going to be an ic acid, an ic acid. All right, so we'll do our examples in just a minute. That might make this a little bit more sense. So the name of the rest of the formula, the non-hydrogen part, if it ends in "ide," it's going to be a hydroic acid. So you'll rip off "ide," you will use a prefix of hydro, and you'll end it with "ic." It'll be a hydroic acid. If the name of the non-hydrogen part ends in "ite," that's an us acid. If the name of the non-hydrogen part ends in "ate," it's going to be an ic acid. All right, so let's do our examples. Maybe they'll help make it a little more sense. This can be a little confusing at first. All right, so first example here, HCl. Cl, when it's part of a compound, when you have Cl and it's part of a compound, we don't call that thing chlorine anymore. What do you call Cl when it's part of a compound? Not chlorine, it's called chloride. Now, if you notice that you've got chloride, the acid that contains chloride, we're going to be using this first line on our conversion chart. Ide is going to go away. We're going to take off the ide, and we're going to instead call it, we'll start with hydro. And so the ide will go away, and it'll be starting with hydro, and then it'll be chlor. Oh, maybe I should stay with the same color. Give me a second. Go back. Hydrochlor. Now, not hydrochloride, hydrochloric acid. So the ide gets replaced by IC, and you actually also start with hydro. So it's hydrochloric acid. All right, let's do some more. A little confusing at first, huh? Let's do some more. All right, so how about that middle one? NO2. Now, NO2, first off, let me ask you, NO2, Is that an element or is that a polyatomic? NO2 is a polyatomic. It's a bunch of atoms, right? So if I can't really show you very easily the polyatomic list on the screen, but if you look at the polyatomic list, you're going to see NO2 on there. And that polyatomic list will tell you that NO2 is called nitrite. Look on your handout, you'll find it. It's towards the top. Now, what do we call the acid that has nitrite? Ite. Well, the way that it works is you're going to rip off the ite, and ite, we're using this one here, ite will be replaced with us. Ite turns into us. So this would be called nitrous acid. All right. Ide goes away, us takes its place. Ite turns into us. All right. Let's do another one. Let's see if this is starting to make a little sense. All right. SO4. I'm going to figure out the name of the non-hydrogen part. SO4. What do you call SO4? Well, first off, is SO4 an element or is it a polyatomic? SO4 is a bunch of atoms together. That's a polyatomic. Now, let's be a little more exact. SO4, if you look on your polyatomic list, you got to dig it out. If you find it, you'll see that SO4 is called sulfate. So we have something in this acid that ends in ATE. If your non-hydrogen part ends in ATE, like sulfate does, 8 turns into ick. 8, we're going to take off the 8, and we're going to replace it with ick. Now, I should tell you, this conversion chart, sometimes there's a little extra spelling change in here. So you might go, well, it's SULF, and then it's going to be IC. That's true, but we actually throw in a couple extra letters. It's actually, it's called sulfuric acid. So it will end in ick. 8 becomes ick. There is a little extra spelling change in there. The only way you know that is kind of like practice and hearing it. You'll realize, oh yeah, this is one of the ones where the spelling changes a bit more than I'm expecting. So this is called sulfuric acid. All right, let's review and let me see if I can give you a few more hints on this. All right, so 8 turns into ick. Ite, take off the ite, replace it with us. That's the middle line in your chart. The top line says, if the name of the non-hydrogen part ends in ide, you're going to take off the ide and you're going to make it ick, and you also use a prefix hydro, so hydrochloric. All right, so it's good to be familiar with all these changes we make. 8 turns into ick. Ite turns into us. Ide turns into hydro-ick. So usually, you know, I make people memorize this. Like doing this online is kind of hard to tell you to memorize it, but you know, you at least should be familiar with that they go together. 8 ick. I ate an icky. Ite us. It's all right. It's just us. I don't know. They go together, right? You got to kind of come up with some way of keeping them straight. All right. So Ide hydroic. I don't even know. I have nothing for that one. All right. So, but they do go together. Now, let me give you a couple other tips that might help you keep them straight. If you have an element, elements when they are part of a compound, negative elements, non-metals, anions, they'll end in ide. So this first line of our chart, this first possibility, this is when the non-hydrogen part of the formula is an element, like chlorine, just like one atom, chlorine in this case. Ite and 8, you might remember ites and 8s, those were the endings for polyatomics. So if your non-hydrogen part of the formula, the thing that ain't hydrogen, if it's a bunch of atoms, nitrogens and oxygens, sulfurs and oxygens, if it's a polyatomic, you're going to use one of the bottom 2 lines on this thing, because polyatomics typically end in 8 or ite. There are a couple exceptions there, but almost always they end in 8 or ite. All right, so with that might help you keep it straight. Now, the other thing that's going to help you keep it straight is let's do a couple more examples, all right? So let me flip to the next page and we'll do another example or two of naming acids. Okay, so let me tell you a little bit about two more examples, okay? So this time I have the charts up. Might still be a little hard to read. If you have them in front of you or another tab open, that might make it life easier for you. But in any case, having these handy will help us out. A periodic table and a polyatomic list, right? All right, so let me write up two more formulas. And I think this time we're going to do H3PO4. And while we're at it, we're going to do HF. All right, so let's start off with the top one, and let's figure out how to name this thing. Oh, first off, are they both acids? Oh, yeah, they are. They're both acids because they both start with hydrogen. That makes them both acids. All right, so we're going to name them like acids. They both start with H. That makes them acids. The first thing you do when you name an acid is you figure out the name of the part that ain't hydrogen, PO4. So first thing I want to ask you, PO4, is that an element or a polyatomic? PO4 is a polyatomic. It's a bunch of atoms. So it should be on your polyatomic list. It's right here. All right. So PO4 is a polyatomic, and if I want to know the name of it exactly, I can look at my handout and it tells me it's phosphate. All right. So what are we going to call the acid that contains phosphate? You're going to take off the 8. You're going to get rid of the 8. And what do you replace 8 with? Do you remember? Or maybe you can check your notes or something. What do you replace 8 with? 8 turns into ick. So 8 will go away, and we're going to end it with ick. So this will be phosphoric acid. Now, again, this is one of these ones where there's actually another little spelling change. So it's not just phosphoric acid. You might think that, right? You might think, oh yeah, phosphoric acid. It's actually, we put another OR in there. It's actually called phosphoric acid. Phosphoric acid. So there is sometimes a little spelling, but the ending, you should be at least able to get that, right? So 8 goes away. It gets replaced by IC. 8 turns into ick. All right, let's do another one. HF. When I look at F, is F an element or is it a polyatomic? It's an element. Now, to be a little bit more exact, when you have F as part of a compound, yeah, F is right here, by the way. Let me switch colors maybe. F is right here. When it's part of a compound, what do you call F when it's part of a compound? It's got a negative charge, in other words. You call it fluoride. So this is going to be called fluoride. Now, how did that work? If it ends in "ide," oh, this is the one where we start it with hydro and we end it with ic. Hydro is going to be the prefix, and then it's going to be hydrofluoric acid. So I turns into hydroic. All right, so with that, last thing I might tell you that might give you a little hint for naming acids is that you notice that most acid names, they don't start with hydro or hydrogen. It's just like phosphoric acid, or like we saw on the last one, what do we see? Sulfuric acid and nitrous acid. Only one out of those 3 lines on the conversion chart did we start with hydro, the top one, this fluoride one, the ide one. All right. So hopefully that gets you a little bit on the right track. Yeah, it's going to take a little practice to get better at this. Let's move on though, and let's do a couple maybe where we're going the other way. So I'll give you the name and you'll have to write the formula. We should be able to do that too. All right. So let's move on and we'll do a couple like that, going the other direction. Okay, so we're going to do a couple going the other way. So now I'm going to give you the name, and you got to turn in the formula, right? If you can go one way, you got to be able to go the other way. So what if you saw somewhere around your house or whatever, and actually you'll see this one on a bottle of soda. Like actually I'm drinking this soda right here, and it says that it contains carbonic acid. Carbonic acid. What the heck? Carbonic acid. What is the formula for carbonic acid? And while we're at it, let's try one other one. Let's say I saw this somewhere. Arsenous acid. All right. How do you name those things? All right, so having the polyatomic list handy is going to help you. Having a periodic table handy might help you too. The other thing is you got to know those conversions. So let me jot them down real quick over here. How did it go? Ide turns into hydroic. And then it was, what was the other one? It was 8. Or no, I think I did ite next. Try to keep them in the same order. Ite turns into us. And then, oh, rats, I need a little more room. 8 turns into ick. 8 turns into ick. Ide hydroic, ite us, 8 ick. All right. So now we're going to think backwards because I want to write the formula. So let's look at the name I have, carbonic acid, ick. Carbonic acid, ick goes with 8. Carbonic acid must contain carbon 8 and it go together, so it contains carbon 8. Carbon 8, is that an element or a polyatomic? Carbon 8, it contains carbon 8, an element or a polyatomic. 8, that's a polyatomic. So I need to look at my polyatomic list to find it. Oh my man, there's a lot of thinking, and especially when we're going backwards now. So carbonic acid contains carbonate. We're kind of using this one right here. Carbonate, if you end in ATE, you're a polyatomic. Oh yeah, it's on here. It's right here. CO3 2 minus. All right, so this is going to be CO3 2 minus. That's what carbonate is. All right, now what do all acids have? All acids, we mentioned a little while ago, they start with hydrogen. Hydrogen with a +1 charge. So if you just write CO3 2 minus, that's not really the entire formula. Because whatever you've come up with, that's just the name of the non-hydrogen part. There's also hydrogen in here, or the formula of it, I guess. So we've got to put hydrogen with it. Now, just like when we did ionic, you got to balance the charges. So hydrogen is always going to be part of an acid. In this case, the other part is carbonate. To get the charges to balance, that's not going to do it. We need another hydrogen. So the right formula would be H2CO3. H2CO3. That's the formula for carbonic acid. All right, let's do our other one. Arsenous acid. All right, got to do the same thinking. Man, it's like making my head hurt. Oh, arsenous. Us goes with ite. Arsenous contains arsenite. Ite and us go together. It contains arsenite. What the heck is arsenite? It's a polyatomic, right? It ends in ITE. It ends in ITE. So if it ends in ITE, it's a polyatomic. I hope it's on this handout. Arsenite. Oh yeah, it's right here. Arsenite. AsO3 3 minus. All right, now that's still not quite done, right? Because you got to also tell me about the hydrogen. It's going to be bonded together. It's going to be joined up with hydrogen. Acids always have hydrogen as well, right? They always start with hydrogen, actually, in their formula. So I've got my two pieces. So this is kind of like doing ionic, right? We got our negative piece. We figured out that was called arsenite. We got our positive piece, which is always hydrogen in an acid. Now, I'm not quite done because I want to know how many hydrogens. So it's like writing a formula for an ionic compound. You have a positive hydrogen and an arsenite with 3 negatives. How many hydrogens will you need to balance out the charges? You're going to need how many hydrogens? You need 3 of them. All right. So if you put it together, the right formula would be H3ASO3. I got a little messy here. Need a bigger screen, I suppose, or something. All right, so that's a little confusing. All right, so I know, again, this is one of these things where, man, I can, if you go back and watch it again, maybe it'll help you. We're gonna stop. That's all the examples I'm gonna do for now of acids. There is gonna be a part C, and in part C, we're gonna put it all together, all this naming stuff, and kind of do a little review of it. All right. So if you have any questions about acids, let me know. I'll try to help you out. Okay. Naming acids. Nope. Where's my mouse?